Hi, and welcome to this demonstration of my snooker application. I will be using the rubric in the coursework instructions to show that my app meets all of the requirements. Let's fire this app up. And let me bring out the console. As you can see by the console, the app runs without error. For the table, I opted to replicate the example image that was provided in the instructions with the addition of adding dotted markers in the D zone for better placement of the cue ball. The table is created using p5.js functions, while the cushions are created as matter.js bodies with the restitution of 1.3 to simulate realistic bounciness. Users can select one of three modes. Number one is the normal set, where it's the normal configuration of a snooker game. They can also select two, which is semi-random, where the red balls are randomized on the table while the colored balls remain in their normal positions. And then there's also three, where all of the balls, the reds and the colors, are in randomized positions. So with the exception of the 1, 2, 3, and the R keys on the keyboard, all of the interaction of playing the game uses the mouse, which will make this game pretty intuitive and easy to play. Once a mode is selected, here I'll select the normal set. The user is prompted to place the cue ball by clicking the mouse in the D zone. I placed a constraint here so that you cannot place the cue ball outside of the D zone. Once placed, the cue stick will appear to show the direction and magnitude of the force to apply. Moving the mouse around the cue ball shows the direction that the cue ball will move in. The guideline here makes it easier to predict the movement. Moving the mouse closer or further away from the cue ball shows how much force to apply, indicated by the force bar at the bottom right. The restitution of the cue ball is set at 1, friction at 0.7, and the force is capped at 0.015. This is to simulate a very realistic movement on the table felt and of the bounciness. The restitution of the other balls is set at 1.2 and the friction also at 0.7. When the cue ball is pocketed like this, the user is prompted to place the cue ball back in the D zone again. Once the desired direction and force are set, click the mouse button to launch the cue ball at the target ball, which is shown at the top here. As you can see, cue ball collisions, ball collisions, and ball cushion collisions are all natural and realistic. Here in the console section, I added a console statement to track the red balls and the colored balls added to their respective arrays. When you hit a red ball, say like this, it removes the red ball from the array. When there are still red balls left on the table and you pocket a blue ball or a colored ball, like so, it returns to its original position, like here. Surprisingly, it is very difficult to line up two consecutive balls to pocket. So here, I'd like to show you the code that I've added to handle this section. When two colored balls or two normal balls are pocketed consecutively, a file message will be displayed saying two consecutive colored balls have been pocketed. For the extensions, I created 4 new features for my app. These features I call power-ups, which appear as buttons on the left side of the app. You'll notice that when your cursor hovers over the button, the cue stick is deactivated. This prevents accidentally moving the cue ball while selecting a power-up. 3 of the features can be toggled on and off. They are increasing the mass of the cue ball by tenfold, shrinking all of the balls on the table by 20%, and a scoring multiplier. Once you click on a power up, an alert will show, showing whether it is active or not active. So, for instance, if I click on cue ball mass times 10 and it is activated, then the cue ball becomes very difficult to push. I can then deactivate this function and it will return to normal. The only feature that cannot be disabled is the alignment feature. What this feature does is it aligns some of the balls by the holes for easy play. Finally, as you can see, I've ensured that the indentation, white spaces, and variable names are named correctly and clearly. I've also provided clear comments to all my code and a commentary at the bottom of the sketch.js file. And that's my app. Thank you very much for watching this demonstration.